Good day, students. Today, we want to discuss on a topic titled differentiation. Under this differentiation, we are going to be considering a fraction. Okay? In our last class, I showed us how we came about Pascal triangle. Okay? Now, when you have 1 here, you bring it to the left and to the right. That's the second line. The third line, you bring this one to the left and add them together. 1 plus 1 2. Bring this one to the right. Next line, you bring one to this side, add it. 1 plus 2 3, 2 plus 1 3. Bring this one to the right. That's how it goes to form Pascal triangle. How do you know the line to use? This is number 1, power of 1, it's power of 0, power of 0 goes for this, power of 1 go for this, power of 2 go for this, power of 3 go for this. That's how it goes down. Now you can see the fraction we have here, x squared is power of 2. I'm making use of this third line. Okay, now when you have y plus change in y, we have the corresponding change in x. 1 over this x is squared, x plus change in x is squared. Some students always ask me, why do I put change in y and change in x? You know, when you have y axis and x axis, as y is changing, you have corresponding change in x likewise. Okay, let me give you an example. When you are advancing in age, when you're in primary 1, for example, when you move your primary 1, you say you are 2 years old, and when you move to primary 3, your age increases as you are advancing in your class. Is that okay? The same thing as y change, you have corresponding change in x likewise. The same thing when you write y plus change in y, you have x plus change in x. Okay, now you now take this y to the other side because we are concerned with dy equals 1 over x plus change in x squared minus y. Okay, now we have dy equals 1 over, when you get to this square, you have this squared here using the power of 2, the third line, and you write x, this first one, x will be squared. Okay, and when x is squared, the x will follow it, the x raised power is 0, and the x raised power 0 is 1. I just put it there so that you know that the x always starts with power of 0, while x squared will carry the power that is being shown here. X squared dx will be raised by 0. The next line, the next expression I will write now is that x will be reducing, will be x raised power 1. The x will now start increasing, but don't forget that this 1 is here by the side, but you don't need to put it. Plus, come here 2. This x will now be x raised power 1. The x raised power 1. See that the x is increasing as x is decreasing. That's the rule. Plus 1, this one, but you don't put it, the x 1. I'll show you something. What you need to write, just write this x squared 0, the x squared, okay, minus y. What is our y? Y is 1 over x squared. We have to write in terms of x because expression at the right hand side is in terms of x, y. The one at the left hand side is in terms of y. Okay, now what we need to, don't write the x raised by 0 in the next line, and x raised by 0, don't write it in the next line because they are 1. Yeah, okay, no need of writing, but I just show so that you see how it's increasing. The x is increasing, y x is decreasing at the same time. Okay, the y equals 1 over x squared plus 2x. Don't need to put 1. X power 1 is still the same as 2x. The x plus the x squared minus 1 over x squared. At this point, what we need to do is to find the LCM. LCM. The LCM is x squared plus 2x dx plus the x squared. Close the bracket and put x squared. All this goes in this. You write this x squared times 1, that is x squared. Now put this negative minus this goes in this to cancel this one out. We use this one to multiply the numerator. That's x, this cancel this, pick this. Okay, now minus 1 multiply by, okay, let me show us how this one cancel this. You use this to multiply the one. Let's write it out so that we're very clear. By 1 minus this, we cancel this, use this, minus 1 minus 1 multiply by x squared plus 2x dx plus dx squared. Dy equals x squared times 1, that is x squared, minus 1 to open all this bracket become minus x squared, negative times 1 times this, negative times 1 times this will be minus 2x dx, minus 1 times dx squared minus dx squared over x squared times that, we are having x squared, x raised by 4, I have to open the bracket, x raised by 4 plus 2x raised by 3 dx. I'm trying to use x squared to multiply all this, whereby plus x squared dx squared. Okay, now let's see what can cancel out. Let's see what can cancel out. X squared cancel this. We are left with minus 2x dx minus dx squared over x raised by 4 plus 2x cubed dx plus x squared dx squared. Now let's factorize out. What's common? You have Alright, minus dx minus dx open brackets 2x plus dx over x raised to power 4 plus 2x cubed dx plus x squared dx squared. Gonna write dy equals minus dx into bracket 2x plus dx over x raised to power 4 plus 2x raised to power 3 dx plus x squared dx squared. Now you multiply both sides by 1 over dx. When you do that, you're having dy times 1 over dx equals minus dx open bracket 2x plus dx over x raised to power 4 plus 2x raised to power 3 dx plus x squared dx squared multiplied by 1 over dx. When you do that, this dx will cancel this dx. What we need to do is that we multiply through by 1 over dx so that it will cancel this out. So whatever I do to the left hand side, do it to the right hand side. Okay. Now we have dy times 1, that's dy over dx equals minus open bracket 2x plus dx over x raised to power 4 plus 2x raised to power 3 dx plus x squared dx squared. Okay, what we need to do now is to find the limits. Limits is that limits as the x tend to limit as dx tend to 0. Anywhere you now see dx, you put 0 there of dy over dx, which is equals to minus bracket 2x plus 0 over x raised to power 4 plus 2x raised to power 3 bracket 0 plus x squared 0 squared. Alright, dy over dx equals just minus 2x over all this one turn to 0 over x raised to power 4. Okay, and you have it from there. One of the x will cancel one of the x. So now it will be minus 2 over x raised to power 3. Okay, you can confirm it if it's the same as when you do the normal differentiation. Let's do it. Y equals 1. I want to follow this. y equals ax raised to power n minus 1 dy over dx equals y equals ax raised to power n dy dx equals a multiplied by n xn minus 1. When you differentiate it, that's when you introduce -1. Let's follow that. Now this one can be written as this: y equals to x raised to power minus 2. Okay, when you remove the reciprocal, you introduce -2. The 1 over will disappear because you have introduced negative. Now let's differentiate this. Dy over dx equals -2 will come to the front, -2 times. There's 1 here before. This n stands as -2. This a stands as the one that is here before, times 1 x is for -2 minus 1 equals to -2 times 1, that's -2, x raised to power -2 minus 1, that's -3. Okay, which is the same thing as this, because this one you can still continue to have it -2 times 1 over x raised to power 3 now be equals to -2. This when you remove 1 over x raised to power -3, which is the same thing as what you have here. Okay, this is the end of our class. Please subscribe to my channel so that I can have access to the latest video. Have a wonderful day.